This is Small Matters, the audio series where we sweat the little things. I'm Ari Daniel. If someone were to offer to meet me in a dark, deserted parking lot in the middle of the night, I'd probably think twice. But I didn't even bat an eye when Jacob Loss suggested it to me, because that was the whole point of our rendezvous. The darker, the better. And that's because Loss is a stargazer.
Just the expanse of the universe is just amazing, almost incomprehensible to what we're used to on our day-to-day lives. And so when I look up, I just take it all in.
This parking lot is on the campus of Emory University in Atlanta, where Loss is a graduate student in astrochemistry.
It's a good night. Beautiful here.
Loss studies the molecules of outer space and how those molecules may have shaped our galaxy and life itself. But first things first, we need to get our eyes on the sky. Loss pops open the trunk to his Jeep to reveal his personal treasure.
I've had this telescope, I think since I was about 10 now. I convinced my dad into getting it for me.
This isn't your average handheld telescope. The whole setup weighs a good 70 pounds. It takes Loss 15 minutes to assemble it in the cold night air. First come a hefty tripod and mounting platform, which secure the actual telescope, a black cylinder the size of a small trash can. Finally, Loss screws a couple counterweights into position.
All right, so everything's set up.
Loss spins the telescope effortlessly, the counterweights balancing every turn. I feel like you're playing an instrument.
An instrument in the dark.
To get things started, he swivels the telescope towards the half moon. Even from a couple feet away, I can see moonlight streaming out of the eyepiece.
Yeah, do you want to have a look?
I'd love to. Wow, it's beautiful.
Once you have a couple looks at one of these things, it's easy to fall in love with the astronomy.
But we're not out here tonight to look at the moon, as pretty as it is. We're after something much less obvious. Loss ratchets up the magnification and swings the telescope towards the bottom of Orion. He scans the constellations slowly until he finds a patch of soft blue mist, something called
the Great Orion Nebula.
And within this nebula, it looks like dark holes have been punched out of the mist. These chunks of darkness are what we're looking for: interstellar clouds, dense accumulations of gas and dust that sit between stars. The reason that Loss studies these clouds, usually with much more powerful telescopes, is because they're the site of some pretty remarkable chemistry.
The first chemical reaction that takes place in the universe is actually just the formation of molecular hydrogen.
That is hydrogen gas, or the stuff that exploded so disastrously on the Hindenburg. And hydrogen gas first gets formed inside these interstellar clouds.
And so once you get these clouds that start to form more molecular hydrogen, they'll become thick enough that they'll help shield the contents to form more rare molecules. And so
shielding from what?
Cosmic rays.
So molecules have trouble forming in the universe because they're being bombarded by this stuff?
Yeah, they're constantly being bombarded by particles or photons that otherwise would just rip them apart.
The interstellar clouds, puffed up with hydrogen gas, provide a kind of protective blanket for other molecules to form and remain intact.
You can start to get CO or
carbon monoxide.
Yeah, carbon monoxide. Then you start to see methanol.
The simplest alcohol there is. Gradually, these interstellar clouds get warmer and build up an inventory of molecules, and it's thought that this process may have seeded the early galaxies over 13 billion years ago, with a set of chemical building blocks that help to form meteors and asteroids and planets, and even, perhaps, molecules tied to the origin of life.
Well, there's another molecule called glycolaldehyde that is almost a sugar.
That almost sugar is made inside interstellar clouds too, and it's been shown to give rise to the more complex sugars we see in living organisms today. Now, this next bit is somewhat speculative, but hear me out. There's some debate as to whether these clouds are the birthplace of comets. We just don't have enough information to be sure. But if it's true, then comets could act as a kind of delivery vehicle for these molecules to get out of the interstellar clouds and end up on planets like Earth. And since comets are full of ice, we may have interstellar clouds to thank for the watery, life-filled world we see around us. And that's what captures Loss's imagination.
That what goes on right in front of us can also occur everywhere else in the universe that we look at. It's exciting to me to be able to make these connections between these two extremes.
All you need, says Jacob Loss, is a big telescope to look deep into outer space, and an even bigger amount of ambition right here on Earth. Our series, Small Matters, is produced by the Center for Chemical Evolution and sponsored by the National Science Foundation with additional support from NASA. I'm Ari Daniel.